34. Consider the function y equals x cubed minus 12x squared plus 1. Find where the function is increasing, decreasing, concave up, concave down, relative extrema, points of inflection. So very similar to a problem we did before, except for this time we have an equation instead of a picture. So we need the derivative. So we are going to get y prime equals 3x squared minus 24x. I want to find a critical number, so I'll set it equal to 0. And I'm going to factor out a 3 and an x. So I've got x minus 8. So my critical numbers are correct. X equals 0 and x equals 8. So if I do a y prime chart, put 0 and 8 on it. Notice I did not call it an f prime chart this time because it's a y equation this time. If I plug y negative 1 into the derivative, I am going to get a positive answer. If I plug 1 into the derivative, I'll get a negative answer. If I plug 9 in, I'll get a positive answer. So that's going to tell me that y is increasing. Let's see, from negative infinity to 0, and then once again from 8 to infinity. And I gave all my reasons in the other problem, so I'm just going to be good with not giving my reasons this time. Okay, so y is decreasing on the interval 0 to 8 because y prime is negative. Okay, and then it did say relative extrema. There is a max at x equals 0, and we would know that it is because y prime changes from positive to negative. And there's going to be a min at x equals 8 because y prime changes from negative to positive. Okay, y double prime, to get the concavity and points of inflection. If I take the derivative again, it'll be 6x minus 24. Let's set that derivative equal to 0. And if you do that, we will get x equals 4. So if I do a y double prime chart, if I plug, let's say, 0 into the derivative, I will get a negative answer. And if I plug 5 into the derivative, the second derivative, I'll get a positive answer. So that now tells me about my concavity. Y will be concave up from 4 to infinity. And that would be because y double prime is positive. And it's going to be concave down from negative infinity to 4. And that is going to be because y double prime is negative. And then there is a point of inflection at x equals 4, and that is because y double prime changes sign. All right, last problem, 35. Sketch a graph with the following characteristics. F of 2 equals f of 5 equals 0. These parts here are about the first derivative, and these parts here are about the second derivative. Okay, so I'm going to, first of all, I'm going to start my graph. I know that at 2 and 5, my graph equals 0. So that's how I'm going to start it. Okay, f prime, I'm going to draw myself an f prime chart. Okay, I see that things are happening at 0 or just at 4. Okay, so the derivative is bigger than 0 for all values bigger than 4. So that means over on the right side of 4, my values will be positive. And then when x is less than 4, so on the left side of my chart, the derivative is less than 0 or negative. So that tells me my function is decreasing until I get to 4, and then it's increasing after that. Okay, and then if I check my concavity, looks like things are happening actually at 2 and 4. Okay, so I know between 2 and 4, my second derivative is less than 0 or negative. Before I get to 2, so to the left side of 2, my second derivative is positive. And then after 4, my second derivative is also positive. Okay, so that tells me my graph is concave up, concave down, and then once again, concave up. All right, and the last thing I would like to look at, when it says the derivative is undefined at x equals 4, that probably means we are going to have a sharp turn there. Okay, so my graph has to go up until I get to 4, and I know it has to go through this point, so I'm just going to put a point up here. I know it has to go up, and I'm just going to kind of do a quick sketch, and then we definitely will change it. We're going to go up till we get to 4, and then we're going to go down after 4, so it's going to look probably something like that. But actually, never mind, because this says decreasing and then increasing. Let's start over again. So I have to go down till I get to 4 and then up. Sorry about that. Okay, now we need to check that concavity. Okay, it's going to be concave up like a cup till I get to 2. So it's going to be concave up like a cup till I get to 2. So we've got the concavity right there. Okay, now after between 2 and 4, it has to be down like a frown. So it's got to switch the way that it's going. So notice now it's concave down, and then it's going to be concave up like a cup again. So there we go, concave up again. So notice we've kind of got a sharp turn there because of the way I had to draw my graph. So I'm going to put some arrows on it, and voila, good to go.